Next topic is Leibniz theorem. So question on this topic is what? State and prove Leibniz theorem. So statement of Leibniz theorem: if y is equal to u into v, where u and v are the function possessing derivative of nth order, then yn is equal to nc0 unv. So un u suffix n means nth order derivative into v nc1 un minus 1 means n minus 1th order derivative of u. V1 means nth first order derivative of v. nc2 un minus 2 v2 plus dash ncn u vn. That is vn means again the nth order derivative of v. And where ncr, the formula for this combination ncr is what? N factorial n minus r factorial into r factorial. So if y is u into v, then yn is this. So if y is the multiplication of two functions, y is in the form of multiplication of two functions, u into v. And if you have to find the nth order derivative, then use this. The proof is by mathematical induction on n. Step first. We know that in the method of mathematical induction, the proof is given in the two steps. The first step is what? Prove the result or theorem for n is equal to 1 or 2 or 3. And in second step, assume the result is true for n is equal to m or k, and prove that the result is true for n is equal to m plus 1. So for the first step, we have to prove the result is true for, suppose n is equal to 1. So let n is equal to 1. So what we have to prove then? So substitute in this theorem n is equal to 1. So we have to prove if y is u into v, then y1 is equal to 1c0 u1v plus 1c1 uv1. This n is 1, so 1 minus 1 is 0. So don't write 0. Suppose it is u v1. So we have to prove this. When we stop these terms, so if n and n, this ncn both are same n and n, then we will stop the terms. So 1c1, if we substitute n as 1, then last term is what? 1c1 uv1 is the last term, and the first term is what? nc0 u1v. So if you substitute n as 1 in this theorem, then we have this as a statement that if y is u into v, then y1 is 1c0 u1v plus 1c1 uv1. So now we have to prove this. So y is u into v, and what is y1? Y1 means its first order derivative. So what is y1? We know that y1 is what? By using u into v rule, y1 means the derivative of u into v, and we know the derivative of u into v is what? uv1 plus u1v by u into v rule. U derivative of v plus v derivative of u plus into v, okay, or v derivative of u. So uv1 plus u1v. So suffix means the derivative. So we write the second term as the first term, and this first term as the second term uv1. And 1c01, 1c0, the value of 1c0 is 1. So right here we have 1c0 u1v, and right here is 1. So write the value of 1 is as 1c1, because 1c1 is also 1. So uv1, and that is we have to prove that y1 is what? 1c0 u1v 1c1 uv1. Hence we say that the theorem is true for n is equal to 1. This theorem is true for n is equal to 1. So this is the first step. Now in the second step, assume that the theorem is true for n is equal to m. That is, what is your assumption? That is, if y is equal to u into v, then ym is equal to, that is, substitute n as m, mc0 um v, mc1 um minus 1 v1, mc2 um minus 2 v2 dash plus mcm uvm. So if y is u into v, then ym is this. So this is suppose star, and this is our assumption, that is called induction hypothesis. So this is the induction hypothesis. It is our assumption. And what do I have to prove in the second step? To prove theorem is true for n is equal to m plus 1. That is, assume the theorem is true for n is equal to m, and prove the theorem is true for n is equal to m plus 1. That is what we have to prove. If y is equal to u into v, then ym plus 1. That is, substitute n in this theorem, n as m plus 1. So what do we have? M plus 1 C0 um plus 1 plus 1 v first term. Then m plus 1 C1 m plus 1 minus 1 means um v1 second term. Then m plus 1, substitute n as m plus 1, m plus 1 C2 um plus 1 minus 2 means um minus 1 v2, um minus 1 v2. In this way, the last term is m plus 1 cm plus 1 u vm plus 1, and this is we have to prove this ym. Okay, so in order to prove this, differentiate this equation star, we get ym, derivative of ym is now ym plus 1. Similar, derivative of y is y1, derivative of y1 is y2, derivative of y2 is y3. That is, add suffix one suffix in the one number in the suffix. Okay, in order to write the second next order derivative. So derivative of ym is what? Ym plus 1, and mc0 now is constant quantity. umv, we have to prove, we have to take the derivative of this quantity by using u into v rule. That is, now first um plus 1 means derivative of um into v as it is, plus um as it is, derivative of v is v1. So u into v rule, that is, keep one function constant and take that derivative of other function. Um plus 1 v plus um as it is, derivative of v is v1. Okay, so the derivative is by using u into v rule. First, what is the u into v rule? U derivative of v plus v derivative of v. Instead of that, use the rule that derivative of u into v plus u derivative of v. Okay, so we have this. Then mc1 is now again constant, the derivative of this quantity. So first take the derivative of um minus 1. So um minus 1 derivative is um. So how we can write the next order derivative? Add 1 in the suffix. So um minus 1 plus 1 is v1 as it is, plus minus 1 now as it is, and the derivative of v1 is v2. So by using u into the, similarly mc2, the derivative of this quantity, first take the derivative of minus 2. It is what? Minus 2 plus 1. That is, minus 2 plus 1 is minus 2, minus 1, v2 as it is, plus now minus 2 as it is, and derivative of v2 is what? v3. Derivative of v2 is v3. Plus so on, plus dash mcm now constant, and the derivative of u vm again by using u to rule. First write the derivative of u is u1, vm as it is, plus u as it is now, and the derivative of vm is vm plus 1. So this is the derivative of this state equation star, and then multiply by mc0 in the bracket, mc1 in the bracket, mc2 in the bracket, mcm in the bracket. We have this step. Okay, then write the first term as it is, that mc0 um plus 1 v as it is, and from these two terms take um v1 as common. So what do we have in bracket? mc0 plus mc1 in bracket, um v1. Now the next, from next two terms take minus 1 v2 common, and so we have in bracket mc1 plus mc2. In this way, plus so on, the last term mcm u vm plus 1. The similar process apply the next, for next step. This, from this term and the next term take this minus 2 v3 as common. From this step and the previous step take u1 vm as common. So don't write that step, directly write the last term mcm u vm plus 1. Then next step ym plus mc0 and m plus 1 c0, both are same, both are values of mc0 is 1, also m plus 1 c0 value is 1. Then you use this factor that mcr minus 1 plus mcr is m plus 1 cr. mcr minus 1 plus mcr is m plus 1 cr. So observe this, mc0 plus mc1 is m plus 1 c1. So here is 1, r is now 1, and r minus 1 is 0. So mc0 plus mc1 is m plus 1 c1, um v1 as it is. Then similar by using the same rule, by using this rule, MC1 plus MC2 is M plus 1 C2 UM minus 1 V2, and MCM and M plus 1 CM plus 1 both are same, because MCM value is 1 and M plus 1 CM plus 1 value is 1. So write MCM as M plus 1, CM plus 1, UVM plus 1 as it is. And this is we have to prove. If you observe this step, what you have to prove? This is what I have to prove. This is what I have to prove. Ym plus 1 is equal to this. And if you observe this step, ym plus 1 is equal to this. This is what I have to prove. And hence we say the result is true for, or theorem is true for n is equal to m plus 1. And hence by mathematical reduction, here second step completed. Hence by mathematical reduction we say that theorem is true for all n belongs to n. So this is the proof of Leibniz theorem. Now we'll see the problem on the Leibniz theorem. The first problem is, problems are also important. If y is sin inverse x bracket square, then prove that 1 minus x square yn plus 2 minus 2 plus 1 x yn plus 1 minus n square yn is equal to 0. So y is sin inverse x bracket square. So differentiate with respect to x. So derivative of y is y1, and derivative of this is by using x raised to n rule. What is the derivative of x raised to n? N x raised to n minus 1. So derivative of this sin inverse x bracket square is 2 sin inverse x bracket raised to 1. 2 minus 1 is 1. Into derivative of sin inverse x is what? 1 by root 1 minus x square. Multiply the derivative by sin inverse x. So shift this root 1 minus x square to LHS. So we get it is root 1 minus x square y1 is equal to 2 sin inverse x. Then squaring both sides. So what do we have? Y1 root 1 minus x square becomes 1 minus x square. Y1 its square is y1 square. And this is equal to 4, 2 square is 4. And sin inverse x bracket square, sin inverse x bracket square is y. And shift that 4y to LHS, we have this step. 1 minus x square, y1 square minus 4y is equal to 0. That is, shift this root 1 minus x square to LHS. And then squaring both sides, we have 1 minus x square y1 square is equal to 4 sin inverse x bracket square, and its value is y. So 4y, after shifting 4y to LHS, we have this step. Okay? 1 minus x square y1 square minus 4y is equal to 0. Then differentiate again with respect to x. Here is, if you observe, the highest order derivative is y n plus 2 order derivative. So differentiate this y 2 times and then apply Leibniz theorem, because the derivative of highest order is of order n plus 2. So differentiate y 2 times. So this is the first order derivative. Now again differentiate with respect to x. So here is u into v rule, 1 minus x square. The derivative of y1 square is what? 2y1 into derivative of y1 is y2. If x, there is x square, then derivative is just 2x, but it is not x square, it is y1 square. So derivative is 2y1 into y2 plus now y1 square term as it is, derivative of 1 minus x square is minus 2x. So minus 2x, y1 square is the second term. Okay. And then minus 4y1, derivative of y is y1 is equal to 0. So this is the derivative of this step. We have this. Then take 2y1 as common, or dividing throughout 2y1. So what we have? If you take 2y1 as common, 1 minus x square y2. Here we have minus x y1 minus 2 is equal to 0. Then shift this 2y1 to RHS. It is divided by 0. So this quantity is not equal to 0. Or dividing throughout by 2y1, we have 1 minus x square y2 minus x y1 minus 2 is equal to 0. After shifting this 2y1. This is the second order derivative. Okay, second order derivative. So if you observe this proof, then it is the highest order derivative is of order n plus 2. So differentiate 2 times and then apply n rule, Leibniz theorem. So differentiating now this equation first, it is denoted by first n times using Leibniz theorem. Where to differentiate this function, this equation n times now. by using Leibniz theorem we have. So this is the 1 minus x square into y2 is now multiplication of two functions, and so we have to find its nth order derivative. So apply the Leibniz theorem. So denote the function y2 as u and 1 minus x square as v. So if you observe this 1 minus x square is not continuously differentiable function. After some order derivative, its derivative becomes 0. Because what is its first order derivative? It is minus 2x. Then second order derivative is minus 2. And the third order derivative becomes 0. But the derivative of y2 is what? Is first order derivative is y3, then y4, y5, y6. It is not equal to 0. This is continuously differentiable function. This is not continuously differentiable function. So denote the continuously differentiable function by u and not continuously differentiable function, that is 1 minus x square as v. And then, then apply the Leibniz theorem. So what is the first term of Leibniz theorem? What is the first term? This is the first term, that nc0. Now it is 1. unv. What is un? Un means the derivative of y2, the derivative nth order derivative of y2, and it is yn plus 2. So the value of nc0 is 1. Then un means derivative of y2 of nth order derivative of y2, it is yn plus 2. Then 1 minus x square as it is, v as it is, that term v as it is, okay, plus nc1, value of nc1 is n, and then un minus 1 means the derivative of u of n minus 1 order. So suffix add 2 plus n minus 1 is n plus 1. So that n value of n is what? nc1 value is n, and then un minus 1 means the derivative of y2 of n minus 1 order, that is add n minus 1 into we have n plus 1. So yn plus 1 means un minus 1 term. Then v1 means the derivative of 1 minus x square of first order is minus 2x. Plus next term is what? The Leibniz theorem next term is what? nc2. So value of nc2 is n minus 1 by 2. Then derivative of y2 of n minus 2 order, un minus 2 term, un minus 2, this term. If you observe the third term, then it is what? nc2, value of nc2 is what? n minus 1 by 2 factorial. Then what is the next term? un minus 2. Un minus 2 means what? N minus 2 order derivative of y2. So add 2 into n minus 2. We have yn as the term. And then v2. v2 means what? 1 minus x square second order derivative. Its first order derivative is minus 2x. Then second order derivative is minus 2. Okay. And what is the next term now? What is the next term? That is nc2, then nc3, un minus 3, v3. And what is v3 now? The third order derivative of v, first order derivative is minus 2x, second order derivative is minus 2, and the third order derivative is 0. So all the remaining terms are 0. So these three terms, first these three terms up to this term, then this term and this term, these three terms denote the derivative of nth order derivative of 1 minus x square y2. Then minus sign, so write in bracket x into y1. Again use the Leibniz theorem. We have to write the nth order derivative of x y1. We have to write the nth order derivative of x y1. So again by using Leibniz theorem, so write in bracket, it is because of there is a negative sign. So the first term is 1c1, nc1, it is 1, and then y1 is now u and x is v. y1 is u, x is v. So first term is what? nc1, its value is 1. un means derivative of y1 of n order, so it is yn plus 1 into v as it is, x term as it is, plus next term is nc1, its value is n. Then derivative of u of n minus 1 order, derivative of y1 of n minus 1 order is what? 1 plus n minus 1 is yn into derivative of v, that is v1, and derivative of x is 1. Then next term is what? nc2 un minus 2 v2, and the derivative of v2 means derivative of x of second order. Its derivative is of first order is 1, and the derivative of second order of x is 0. So v2 is 0, and so then all the remaining terms are 0 now. The next, this V2 is 0 now, V3 is 0, V4 is 0, V8 is 0, and therefore all the remaining terms are 0. And so two terms, these two terms right here in this bracket are the derivative, nth order derivative of x, y1. Minus 2, derivative of minus 2, first order derivative is 0, and so nth order derivative of minus 2 is 0. So is equal to 0. Derivative of minus 2 is 0, nth order derivative of minus 2 is 0. Because first order derivative of minus 2 is 0. So obviously nth order of derivative of minus 2 is 0. And then arranging these terms. So this term 1 minus x square yn plus 2. Then uh, this term minus 2 nx yn plus 1. Then these two get cancelled and we get minus n minus 1 yn this term. After negative effect of negative on these two terms, we have minus x yn plus 1 minus n yn is equal to 0. And then collect the term, this term as it is, and out of these two terms, yn plus 1, yn plus 1, take x yn plus 1 as common and negative sign as common. So we have 2n plus 1 in bracket. After taking x, yn plus 1 and negative sign common, we have in bracket 2n plus 1. And out of these two terms, take yn as common, so and negative sign common. So this term is n square minus n, and so n square minus n and this minus plus n get cancelled. So we have n square yn as well. This is n square minus n. So take negative sign common. So what do we have in bracket? N square minus n plus n. So it is n square minus n square yn is equal to 0. And that is we have to prove. So we have to prove this, that 1 minus x square yn plus 2 minus 2n plus 1 x yn plus 1 minus n square yn is equal to 0 if y is hypothesis. So we will see the remaining problem on this theorem in the next lecture.